Okay, this is our last lesson for this unit. We're just going to do a little review of sections 5 and 6. We're going to start with simplifying, and number one, remember when we simplify rationals, we need to factor first. And so we've got to recognize the different kinds of factoring. This is a difference of two perfect squares. And so when you have a difference of squares, you have two parentheses. The square root of the first term goes at the beginning. So the square root of 16 is 4. And the square root of x squared is x. That goes at the beginning of both parentheses. The square root of the second term goes at the end of both parentheses. And then one's plus and one's minus. And that's only if you have a difference of two perfect squares. On this one, it's not in standard form, so the first thing I would do is make it in standard form, so it's minus 4x plus 3. And then if your leading term is negative, then it's really important to go ahead and factor out a negative 1 or a negative, if there's a coefficient term that you can factor out. But we're going to factor out a negative 1. Negative 1 times 4x gives me negative 4x, and negative 1 times negative 3 gives us negative 3. And by factoring out that negative 1, we're able to simplify the 4x minus 3's, and then I have 4x plus 3 over negative 1, or we can pull that negative out in front and say negative 1 times 4x plus 3. I would take either one of those. You might want to talk to your teacher in that situation as to what form both are technically correct. Okay, next part. When we're adding or subtracting rationals, we have to find a lowest common denominator. And we need to factor each of these terms to find out what our lowest common denominator. So x plus 2 can't really be factored, so just that term is there by itself. On x squared plus 3x plus 2, if you factor that, our leading coefficient is 1, so that's one where you can find the factors of 2 that add to be 3, and of course the only factors of 2 are 2 and 1. So this is x plus 2 and x plus 1. So the lowest common denominator is going to be the one that they share. You write that down once, and then everything else is also written, and that's my LCD. And notice the second fraction already has the LCD, so we're not going to really do anything with that. The first fraction, we have 3 over x plus 2, but I have the x plus 2, I also need x plus 1, so I'm going to multiply the bottom times x plus 1 to get my LCD. But whatever you do on the bottom, you also have to do on top. This is subtraction, so we're going to have to be really careful of that. And then on the bottom, we have x plus 2, x plus 1. And we don't have to do anything with that, so there's nothing to multiply on the top because there's nothing that you need to multiply on the bottom. The next thing I'm going to do is within each fraction, I'm going to simplify those numerators. I'm going to distribute the 3 here, so I have 3x plus 3 over that LCD minus 4 over my LCD. And whenever we have subtraction, you change the subtraction to addition and then change the signs of everything that follows it. So that becomes a negative 4. So then when we combine like terms, we have the only x term we have is 3x. So we have 3x plus 3 minus 4 is a minus 1 over our LCD, which since we're at the answer, I'm going to go ahead and write the LCD out. X plus 2, x plus 1. Right. So when you add and subtract, that's when you find the lowest common denominator. When you multiply and divide, as in number 3, we have to factor and cancel. And the only difference between multiplication and division is if it's division, you change it to multiplication and you flip the fraction that follows. So this is going to become 3y squared minus 3y. Okay, these two change places. And y squared plus 2y minus 8. The first fraction doesn't change at all, it just stays as is. You only flip the part that comes after the division. Now, in order to simplify this, we're going to have to factor every numerator and every denominator. This first one, I can factor a 4 out of that, so I have 4 times y minus 1. On the bottom, I can factor out a y, so I have y times y minus 1. On this side, I can take out a 3y. 3y times y gives me 3y squared. 3y times minus 1 will give me negative 3y. And then this is a a trinomial with a leading factor of 1. So I need numbers that multiply to be 8 and add to be a positive 2. And that'd be 4 and negative 2 that multiply to be 8 and add to be 2. So this is going to be x plus 4, x minus 2. And then I'm going to simplify where I can. I've got, nope, I think I made a mistake here. If I factor 4 out of here, this isn't y minus 1, this is y minus 2. There we go. So pay attention to that. Y minus 2 and these aren't x's, these are y's. See, if you guys were live in class, you would have caught that and you would have stopped me. Alright, so y minus 2 and y minus 2. Y minus 1 and y minus 1 can simplify. There's a y here and a y here that can simplify. And then what we end up with is, on top, all we have is 4 times 3, which is 12. And on the bottom, all I have is y plus 4. And so then that's the simplified version of that. When we're dealing with radicals, first we need to simplify the radical, and then if they're like terms, then we can combine like terms. But we're going to start with number 4, and everything that's under the radical we're going to pull apart. This is a cube root, so I have 2x's already out to the side, and then I have the cube root of 16. I have the cube root of x, and the cube root of y to the 6th. 2x is already out. Whoop, move that over. The 2x isn't under a radical, so it's just going to stay 2x. What I'm looking at here is there a perfect cube that goes into 16? And now, what gets confusing sometimes is we're so used to looking at square roots and squares that you see 16 and you want to just find the square root of that. This is not a square root, it's a cube root. So what's a perfect cube that divides into 16 evenly that we can pull out? And 8 is a perfect cube. So if I take the cube root of 8 to the cube root of 2, this simplifies to 2 cube root of 2. I still have the 2x out here. All these things are being multiplied. This is x to the first. I can't divide. 1 cannot be divided by 3, and there's not a number that's less than 1 that can be divided by 3, so there's nothing I can pull apart and simplify here. So this is just going to stay the cube root of x. On this one, I can actually divide. 6 divided by 3 is 2, so this one can solve. And 6 divided by 3 is 2, so this becomes y squared. When I put this back together again, everything that's not under a radical gets multiplied together. So I have the 2, and the 2 times 2 is 4. And then I have an x and a y squared. And then under the cube root, I have a 2 and an x. Okay, so that's the simplified version of that first term. So we're going to go through the same process with the second term. I have a 4y squared out here, and then I'm going to divide this up. I've got the cube root of 54 times the cube root of x to the 4th. 4y squared, nothing's happening to that because it's not under the root. Looking for a perfect cube that goes into 54, and a perfect cube that goes into 54 is 27. So this is the cube root of 27 times the cube root of 2. I solve this, the cube root of 27 is 3. And then the cube root of 2 stays under the radical. Here, 4 does not divide by 3 evenly, but I can break that apart into x cubed, the cube root of x cubed, and the cube root of x to the first. And when you pull this apart, I want this number to be something I can divide by 3 evenly so I can solve it. 3 divided by 3 is 1. So the cube root of x cubed is x, and that one I cannot simplify any further than it already is. So now when I pull this one together, everything that's out in front that's not in the radical gets multiplied together. So I have a 4, I have an x, and I have a, nope, 4 times 3, so that's a 12. Because the 3 is on the outside here, so it's 12x, y to the second, 4 times 3, the y to the second and the x, and then under the root, I've got a 2 and an x. And these things are being added together. My term for both of these is the cube root of 2x, and those are the same term. So I can combine like terms. I've got 4xy to the second and 12xy to the second. These are the same terms. So 4 and 12 is 16x y squared times the cube root of 2x. Okay, number 5. No rats in the basement. I've got a radical in the basement here, so I'm going to multiply by the conjugate of that. So this will be 2 plus the square root of 10, but whatever you do on the bottom, you also have to do on the top. On the numerator, I'm going to take the 4 and I'm going to distribute it. 4 times 2 is 8. 4 times the square root of 10. This is not a radical and this is, so I have 4 square roots of 10. I can't really combine those because they're not the same. Down here, I'm going to make these, I'm going to FOIL these. 2 times 2 is 4. 2 times the square root of 10 is positive 2 square roots of 10. 2 times negative square roots of 10 is negative 2 square roots of 10. And then the last one, I have a negative times a positive is a negative. And then under the radical, since these are both under the radical, I can multiply those together. 10 times 10 is 100. So that gives me 8 plus 4 square roots of 10. The 2 square roots of 10 minus 2 square roots of 10 simplifies. So I have 4 minus the square root of 100 I can solve, that's 10. So that gives me 8 plus 4 square roots of 10 over 6. Since all of my whole numbers and coefficients are even, I can factor a 2 out of all of those, but it has to be all 3 parts. It has, whoops, sorry about that. It has to be all 3 parts. It can't just be these 2 or just these 2. But if the whole number, the coefficient, and the whole number in the denominator are all numbers that can be simplified, you simplify it by that number. 2 goes into 8 4 times. 2 goes into 4 twice. 2 goes into 6 3 times. And that's as far as I can go. I can't simplify here, even though 4 and 2 both have a number that go into those, because the 3 does not share that property. And so then that's the final answer for that. Oh wait, this is a negative 6 though, so this is a negative 3 here. Just making sure we got that right. Okay. Remember, when you have a rational exponent, this is actually the exponent part is the top. Roots go underground like they do with trees. And so the bottom number is what you take the root of. And then you always do the root first. So this would be the cube root of 27/8 squared. You do the root part first. So I'm going to take the cube root of 27 and the cube root of 8. Cube root of 27 is 3. Cube root of 8 is 2. And then all of that's being raised to the second power. 3 squared is 9. 2 squared is 4. Okay, here I'm going to simplify what's inside the parentheses first. 2 goes into both 2 and 6. 2 goes into 2 once, and 2 goes into 6 3 times. So I'm going to simplify that. This is x to the first. So I've got 3 in the denominator. And then my x, I'm going to take 1 minus 1/4, which is 3/4. So this is x to the 3/4 over 3, all of that squared. If I take 3/4 times 2, that's 6 over 4, which is 3/2. So this becomes x to the 3/2. 3 to the first squared is 3 squared, which is 9. Just make sure you follow your order of operations and do one step at a time. Okay, we're back to multiplying numbers and radicals. 3 times the square root of 5, I can't combine those because one's under a radical and one's not. So this is 3 square roots of 5. But when I take the square root of 5 times the square root of 8, that's the square root of 40. I could stop there, but I need to make sure that none of this can be simplified. There's not a perfect square that goes into 5, so that part is as far as it can go. But 40, 4 goes into 8, or 4 is a perfect square that goes into 40, and that's 4 times 10. Square root of 4 is 2, so this is 2 square roots of 10. And I have 3 square roots of 5. And I can't combine those any further because they aren't like terms. I have the square root of 5 and the square root of 10, so that's as far as that can go. But do simplify it and make sure that you've taken it as far as it can go. This one we're going to FOIL, so my first term is 2 times 1, which is 2. My outside term, 2 times negative square root of 8, is negative 2 square roots of 8. One's a radical and one's not, so you don't actually multiply those numbers. When I multiply positive 7, square root of 7 times positive 1, that's positive 1 square root of 7. Now when I multiply these, I have a positive times a negative, which is negative. 7 times 8 is 56. Since they're both under the radical, we do multiply those together. And so I have the square root of 56. We're going to break those down as far as we can. There's a perfect square that goes into 8. That's the square root of 4 times the square root of 2. So I have 2 minus 2 times that. Square root of 4 is 2. 2 times, so I've got 2 times 2 out in front of that, so it's 4 square roots of 2. Square root of 7 can't simplify at all, so this is still plus square root of 7. 56, you can have 4 goes into 56. So square root of 4 times 14 is 56, so I can solve that. This is minus, square root of 4 is 2, so 2 square roots of 14. And notice I've got a whole number, I've got the square root of 2, square root of 7, square root of 14. There's nothing else I can do with this, so my final answer is 2 minus 4 square roots of 2 plus the square root of 7 minus 2 square roots of 14. And that's the simplified operation there. Okay, so that's a good overview of all the different rules for this next test. Good luck!